That doesn't count.
It totally counts.
Welcome to the AI show. I'm Scott Stephenson, co-founder of DeepGram. With me is Jeff Ward, a.k.a. Susan. He's a Navy pilot, acclaimed dad joke writer, and AI scientist at DeepGram.
Hey, y'all.
On the AI show, we talk about all things AI. What is it? What can you do with it? How does it affect you? Where is it going? Where is it all going? We are live and ready to answer your questions. Comment on YouTube and Twitch or tweet at DeepGramAI to join in. Today, we're asking the question, the very big question, what does it mean for a machine to learn?
Yeah, what does it mean? What does it mean for, what does it mean?
Yeah,
Scott,
I don't know. What does it mean?
what do you think it means for a machine to learn, Scott?
I mean, I think a basic way to look at it is a machine altered after you give it some data or something like that, or you expose it to an environment, has it changed, and usually changed for the better or something, right? Of course, you could take like a car wash and then drive a semi truck through it, and then it just destroys the car wash or something. But that probably isn't better.
Well, I don't know. It's open up to the sky. The rain can come down. You've got larger
maybe.
volume
Yeah,
then, right?
yeah.
I mean,
yeah. But like if you wanted to teach a child to read or something, maybe you show them, hey, this word means this, these sounds mean that, etc. And then they try it, and then you say like, yeah, good job, or not, or something like that. And then the next time they try to read, do they like get better? Do they remember some things? Do they do things like that? So I mean, these are humans learning or an animal's learning, doing a similar thing. Similar thing with a machine. Do you give it an image? Do you give it some audio? Do you give it some text? Do you give it some you clicking on a spot on a website when you're about to buy some shoes, but it helps, but it learns from that and it gets better at doing whatever its job is, and so that's really machine learning.
it seems like the definition's really wrapped around one really important word: better.
Yeah, gets better.
Better, and that's a really squishy word in some certain problems.
Oh yeah.
I mean, how do we define that better? Like, I that kind of gets into what makes certain problems tractable nowadays. If we can really tightly nail down what is better, we're generally pretty good at it in the computer world and the machine learning world. But if better is kind of a little bit squishy, like, are you better at playing basketball today than yesterday? Those get into harder and harder questions. And then like, is this better solution to world peace?
Those things can get complicated.
Yeah. So, that kind of brings up an interesting question of, what are the kinds of problems that computers can do or that machine learning can kind of attack nowadays that humans can do? And what are the things that humans can't do? What are your thoughts on some of the ones that humans can do that machines are having a problem with today?
Yeah, you kind of have it. You have it all four ways essentially, right? Some things humans can do and machines can do. Some things only machines can do or do well, and humans can't do them very well. Examples of that would be like have a person pick up a house. Okay, machines can do that better than a human can. But then you can have it the other way around. What can a human do better than a machine, or what can you have that none of them can do very well, basically, right? But yeah, the most interesting part is probably like, when does a human do a better job than a machine, or a machine do a better job than a human, or like what factors go into that essentially, right? And so like to come back to the standard topics of like images, text, audio, time series, like where you click on a web page, what's the next thing, what's the next ad I should show you, or something like that. Usually what can happen is a human might be able to do a better job than the machine could in like normal context in the normal world right now, but they would be way too expensive to have them make that decision essentially. So if you had a person sit down and like learn all of the dog breeds in the world and really study pictures and give them infinite amount of time and pump them full of Mountain Dew and Papa John's, or Dr. Pepper in your case, right?
Dr. Pepper and Cheetos, thank you very much.
Okay, sorry.
All right.
Yeah, and then say like, really sit down and think about all this, and you get all the time and all the money in the world to figure these out, and then submit your answer. They still might be able to do better than a machine, but a machine would be able to do that in like 500 milliseconds.
Yeah,
I just ran through all of them, and then here it is, and maybe I'm a few % off, but big deal. It was super cheap for me to do it.
And that's really, and in the world of machine learning nowadays, it's the big data problems that machines are starting to edge out humans on.
Yep.
You know, when you've got these just tremendous data sets, like you were saying, you know, dog breeds or something that would take an expert a whole lot of years to get really good at. That's where machines are starting to see some good advantages. But
yeah, also when it's just it's complicated, but it's not that complicated, kind of. You know, there's a lot of things to remember, but it isn't that they all interact with each other and form some complicated mess. So it's complicated simply because of like how numerous it is or something. Then that's really good for a machine to tackle that. They can handle that cognitive load of like juggling a lot of different, very simple things. But if they all have to interact, then it usually doesn't work out as well. Like, for example, if you wrote an article and said, "Hey, machine, summarize this article for me." Well, if a human sat down and read that article and they said, "Well, a few main things are these, you know, and here's the summarization," then you would be able to listen to that, feel like you had a good idea of what that was. Not every human would give you the same answer, though, right?
Yeah.
But a machine probably doesn't even come close nowadays. Still, you know.
And I think that again, you're nailing, you know, from my point of view, one of the big distinguishing pieces here that says where machines aren't doing well also is tied to where humans give you a lot of different answers.
Yeah.
You know, so if I were to summarize a book for you or something like that, you know, I'd get a very different summary than you, as you just pointed out. If I were to give you my impressions on a painting, or if I were going to do different things. And at that core of the different answers, none of them are necessarily wrong. Some will say we feel more right or feel more wrong. But that's the core thing, like this idea of what is better and what is worse in a squishy world.
Yeah.
That's where
subjectivity is flowing in there a little bit.
That's where human problems are really, really working out. If there's some very standardized, accepted answer, then you build a training set out to do a highly supervised learning technique, and we're starting to learn how to do that fairly well. It's that unsupervised, semi-supervised, coming up for what the definition of good is that machines are a little ways away on.
Yeah, people are trying. I mean, there are people in the world trying to do summarization on large bodies of text and make it work. And
they're getting better.
You know, more progress keeps being made, but it's usually in the context of where a human could look at something fairly quickly and give you a quick snap answer on it, is where machines tend to do a fairly good job still. You know, so in the case of autonomous cars or something, hey, you're driving in a street, you see a person, you know, should you stop or not? Okay, stop. Pretty easy. It didn't take me very long to compute that as a human. Didn't take me very long to compute that as a machine either. But something that's like more in depth and complicated, you know, I have to think about the sequences into the future or read a long document or something like that. And then it's like, oh, it's not such a split second decision for me. And then humans it takes more cognitive load for them to figure this problem out. But machines they can't do it at all yet.
Yeah. So that gets to what's really holding machines back from getting into that space. What's your take, Scott? I mean,
I think there's a couple areas, right? It's like, do you have the labeled data for some of it, you know, and then for some of it, it's also, do you have the model architecture that will actually work? And I think in both cases there, you can find examples where you don't have enough data or any data at all. And if you did have data, that problem would be solved. But then also you could find other cases where all the data in the world still isn't going to fix the problem until you find a new model architecture that can actually support that data and be trained and learn from it. So like one of the things that humans do pretty well is they can take, like when you're learning speech in language, you can work from a few set of small examples. You can talk to people in a normal way. And then when maybe you hear a word that you don't understand, but you can start to like work out context, and maybe even weeks later you see it used in another context, etc., and you stitch it all back together. And that was a totally unsupervised way of learning that what that word meant. That's how people like learn a large amount fairly quickly, you know, over 10 years of their life, and in the long tails as well, without seeing any real supervised part of it. But yeah, it's like a tricky problem.
It's really hard. I do think that there's an aspect though that's pretty important, and that is going back to humans have an ability to kind of pick their own loss function.
Yeah.
Right. And this is a key to any kind of problem you've got. Basically, any machine learning problem, you got to know what's better and you got to know what's worse. And humans, we all have this ability to say, I think this is better and I think this is worse.
Mm-hmm.
And we learn to make these loss functions a little bit better and a little bit worse. You know, you have a different set of loss functions than I do. Mm-hmm. And that is at a really tight core of our ability to go into these semi-supervised and unsupervised worlds, is to develop that loss function, start understanding how we can come up with a way of attacking the problem. And the first step is just say, did a little better or did a little worse this time, and then changing that.
Yeah, machine learning, these machines, and when they're doing machine learning, AI, deep learning, etc., they have a lot of freedom in certain areas to do whatever they want to do in order to like figure something out. But they have very strict rules in other areas that are like the only thing that you care about is making this number go up. They don't even know what the number means. They don't, whatever. All you got to do is make this number go up. In aggregate, maybe across your whole data set or whatever, but you got to make that number go up. And so you're very constrained on that. But you know, you can fiddle with all these numbers if you want to try to make that number go up. But that's your job. That's what it is. Humans can use common sense to be like, that's a stupid number to be trying to optimize. Where an AI algorithm doesn't do that yet.
Yeah, that's a huge challenge, being able to kind of figure out your own loss function. Once we can get there, I think that, you know, the research into that area will lead to good general purpose artificial intelligence and really crack a lot of problems. You know, as soon as we start allowing that hard fixed loss function to be modified itself and come up with good ways of dealing with that, so it doesn't, you know, get out of control and destroy everything. That will really open up a lot of the missing problems, the problems that machine learning can't tackle right now.
So some things that computers are really good at that humans aren't is like, go multiply 10,000 numbers, go, right? You know, no problem for a computer.
I'd get it wrong off the third one, you know, like
give up,
you know,
go sulk in the corner.
My son keeps saying, "Oh, I can count to 1,000," and he starts counting, and you know, 50 suddenly turns into 72, and you know,
trying to jump ahead a little bit.
Yeah, you get lost. I mean, there's you get bored.
Yeah.
Computers don't get what's the line from Terminator? It never gets bored or never gets tired.
Never gives up.
Yeah, there you go.
Keeps coming.
The Terminator could do a lot more than 10,000 numbers.
That's true.
I'll bet you that thing could crunch some serious numbers.
Yeah. So one thing we didn't necessarily talk about a lot is just what unexpected thing, or maybe unexpected, unintuitive thing, whatever, will a machine be able to do better than a human in the future? You know?
Ooh, that's such a wide field. I mean, we kind of talked about a generic area, you know, things that are big data, but I'll tell you the one that's coming up quick, and everybody sort of gets this, but I think that we'll really see when the numbers come out. That's self-driving vehicles. Like this is one of those things that people think is a highly intelligent task. But I honestly think from a machine learning standpoint, we're seeing how much easier it is. Let me give you an example of how easy the task is. When you drive 150 miles, how much of that route do you remember?
Yeah.
Almost none.
Yeah,
why is it? Because you've kind of automated all that in your head.
Just whatever.
That kind of problem where you can kind of automate it in your head, that means that it basically is a soluble problem so long as we can figure out those little pieces that went into it. And computers are just going to destroy us. They're going to be a lot better at doing it, a lot safer. They can look in a lot of different ways. They can see in 18 different spectrums that we can't. You know, they can avoid that cat and get you to your destination on time.
Same thing with figuring out, is this a cat or a dog or whatever. You don't think like, well, it's got an edge of an ear and it's got whatever. It's like, it's a cat. You know,
definitely a cat.
Yeah.
The machine will be like, it's a cat.
Yeah.
It's like, but it could.
If you don't have to think about it, then
it's a cat.
Yeah.
So those problems are a little. People don't. I don't think people understand it, but any kind of problem where you can just go on autopilot. Where you've gotten to a level of mastery of something where you just don't realize it at the end of the task. Those are probably, all of those are going to be where machines will eventually get better than us.
Yeah.
The ones where you are always constantly thinking and being creative and coming up with, oh, but we hadn't thought about this, and that takes you down a new road, and we hadn't thought about this, and it takes you down a new road, and you're mentally engaged the whole time. Those are the long, hard
Yeah.
far away
It's
problems.
not a closed system that you can just let machine learning or AI just play in, right?
Yeah.
And say, like, go figure that out. It takes even a while for humans to figure out what loss function, what reward system they would set up for a machine to, like, go learn that.
Yeah, and it's going to be interesting to see which problems start falling into that fully automated world versus which don't. But there's one other aspect of this. It'll also, by automating all those problems, just to get a little off here, people are worried about machines automating everything away. The reality is they're going to take the 95% that's boring and leave the 5%, and that 5% will grow. And that 5% will allow us to focus on the really interesting things and not be bored all the time. You'll probably have more people just like, I need some downtime because I'm thinking too much.
Yeah, it already happened. You had like mules and oxen and things like that turning mills to grind flour back in the day, or you have steam power doing things that humans would have done, or like a tractor, rather than having the mule, go plow the field, etc. Like, you see those types of things already being displaced now, and it's just it freed up time for humans, and so that's the evolution of things, and that's going to happen again. And people would talk about like the Industrial Revolution or the Agricultural Revolution or whatever, like displacing jobs or something like that. It totally true does in a short period of time, but then people fill in the gap and start doing more creative things. So yeah.
So we throw around a lot of terminology all the time. It might be important just to point out things like, what is a loss function? What, when we say loss function, cost function, all these different things.
Reward function.
Generically, what we're talking about here is an observable truth and comparing our prediction to that.
Yeah.
And how far away we are between those two. The real answer was 18.2 and we guessed 18. There's a certain,
you're not too far off.
There's a certain gap right there.
But maybe that is really far off.
It could be. It depends on your scales here. Maybe you could only predict between 17.9 and 18.3.
But if it's like cat or dog, you're building a cat or dog detector, or hot dog or not, and it says 80% hot dog, 20% not, right? Then okay, fine. What was the original? The original was not, and it's like, oh, I'm really far off. I said 0.8 on hot dog, but 0.2 on not. Right?
Yeah, and that's another.
I should have been 1 on not and 0 on hot dog. Right?
And that's also another interesting point. When we talk about how computers or machine learning predicts, generally, not every time, it's not this binary 0 or 1 world. We turned it into that.
Yeah.
But a lot of problems, especially classification problems, come down to a probability of one class versus a probability of another class. So when we talk about loss functions, the ultimate is to predict 100% on this and 0% on everything else.
Yep.
So even if you say predicted 80% on the right class, there's a little bit of gap there. You should have been 100%, right? So we've got, when we talk about loss, we're talking about, compared to the perfect absolute truth there.
Yeah. Yeah, where it would be marked as 1 not hot dog, 0 hot dog, Yeah. But the next example might be a hot dog, and that was a 1 hot dog, and it's a 0 not a hot dog, right? Yeah. So. But having some room for ambiguity there makes some sense. Maybe the times that it guesses like half one, half the other, it actually is like a half-eaten hot dog. I don't know, but
there's a lot of things that are called hot dogs out there that I'm not sure are actually a meat product.
Yeah, that's a good point.
I mean, there's something tubular shaped, and there's some sort of bread-like object around them.
Yeah.
And I don't know, anything you get for $1 on the street, probably you might want to question. And I'd put a 50 on that personally. I'd be pretty questionable.
Like anywhere on the street in the Mission?
Oh, definitely.
Yeah. A bacon wrapped hot dog here?
I've done this.
Yeah.
I've done this.
That's not a real hot dog for sure.
But
it still tastes good.
It's so
at
good.
2 a.m.
Yeah, at 2 a.m.
Yeah. So we probably can't talk about like what does it mean for a machine to learn without talking about intelligence a little bit. Like what is intelligence?
Ooh, what is intelligence?
We said like what is learning a little bit, right? But what is intelligence?
Yeah. So intelligence is a really hard thing to nail down, and especially when it comes to machines. Like, there's a very good chance, a very real chance, the first alien species we'll meet will be a machine, i.e., we create it somehow and suddenly realize it's intelligent. But there's also a really high chance we'll realize it too late, meaning it was intelligent for a while, but it was so alien to us.
We didn't
understand it. When we think of intelligence, we always think human intelligence. You go out into the animal world and you see things that humans couldn't possibly do from a mental standpoint, and yet we don't call them intelligent, at least self-aware, like we would think of as ourselves, right?
Yeah.
So there is no one answer. This is what intelligence looks like.
People tend to define it, though, like, what can a human do that's hard? Pretty much. Oh, can you speak some sound waves and a human can turn that into words? Okay. Can you show a human an image and they can tell you, like, what the object is? Like, okay, these are intelligence tasks.
Yeah, the big ones are, can you get some new thing that you have very little experience with and come out with some sort of acceptable set of answers on the other end?
Yep.
That takes a really high level of function to be able to come up with something like that.
Yeah,
and that's really, again, why we're pretty far away with it in the machine learning world, right? Everything that we do in the machine learning world, maybe you can say there's a little bit of creativity starting to happen with some good random dice rolls, but for the most part, it all fits within a bin, 1 single millimeter outside of this bin, and the machine doesn't know what to do.
Yeah. Yeah, I think there's an interesting point to be made about when there are sort of underlying laws or rules that can't really be broken, but there's sort of chaos around those rules, and it's kind of hard to figure out what they are, et cetera. Like, it's not that hard to drop something and say that things always drop, right? But it is kind of hard to predict the weather or something. But are there underlying rules on how that works? Like, yeah, and so essentially, intelligence is maybe discovering some of these laws as well. Hey, you're given this mess, right? But there are these underlying rules that you don't know what they are, but you sort to discover them a little
Figure
bit.
out the system.
So just like language, if you just started spitting out a bunch of different words, like, it literally would be gibberish. It would be, take the age of the universe for you to spit out 10 paragraphs that actually make sense if you did it randomly, essentially, right? But there's some rules, there's some structure, there's some whatever, and you start to discover those things and you hang on to them, but then you move away from that structure just a little bit, and that's what creates the fuzz around the world, et cetera. But you can look at, like, how does the earth, like, form, and water and eddies flow and things like that, just stuff like that. There are underlying rules of how fluids move and how gravity affects things and how molecules break down and whatnot, and then you can say, like, look, that's how it is. But if you look from the outside, it kind of looks like chaos.
Yeah, so our ability to figure out those systems and then use that knowledge to figure out the future is definitely a big portion of how we are intelligent.
Yep.
But again, it's really hard to say what will the first other intelligence we meet look like, and how will it be similar to us? How will it be different to us? Will it be extremely, quote unquote, better? Again, defining this, what is better, what is worse here. That will be an interesting thing, and it'll be a challenge for us. There's a lot of morals and ethics that go into this, which we could probably spend hours on just that subject alone.
Yeah. I think there's a lot of there's been a lot of iteration and time for this to sink in sort of the data science community, tech companies, et cetera. They're figuring out how to show ads to people really, really well. Probably better than a human can. Like, almost certainly, I would guess, at least on the scale that we're talking about.
Yeah, well, that gets down to people are actually fairly predictable when you find a niche that they're staying in. So, if you get into a routine, obviously you're predictable. That's the point of routine. One of the first things I played with when I got in the machine learning world was doing a simple 0 or 1 predictor. You would type in zeros and ones, zeros and ones, zeros and ones, and then after a certain amount of time, it would guess and not tell you what it thought your next one would be, a 0 or 1, et cetera, et cetera. And then at the end, it would say, I was this % right. And it stunned me. It was like 80 some odd % right. I'm pulling a number out of here. You think you're being random. You think you're being random, but in reality, you're incredibly predictable. You're coming up with patterns all the time and following them. So this is one of those things we were talking about before. What is it that computers might be, machine learning might be able to do that's pretty interesting. it's predicting humans, even though we say humans are so hard to do.
Yeah.
Within certain scopes,
Yeah.
humans are incredibly predictable.
Yeah, and within a certain accuracy that you're willing to, give up. Like, hey, I don't have to be right 100% of the time.
No, yeah. I mean, if you can predict 80% of the time, that's
great.
really good for a lot of things, right?
And it's not going to get tired either, the machine. So.
No.
But like predicting your next Amazon purchase or something, hey, you go buy something and it says like, look at these 8 things. And it's like, actually, yeah, I kind of wanted that one too.
Or more interestingly, predicting what to show you to guide you to the more expensive purchase.
Well, that too, yeah.
That's a really fun and interesting world to get into.
Yeah, so I think now currently like state of the art, really good stuff is happening like in ads and recommendation systems and things like that.
Where the money's at.
Yeah, where the money's at, where the data's at. People interact with it and train it really well, and that's for sure. And images, text is coming around, audio is coming around, and like time series type stuff is coming around. Driving cars and whatnot is coming around. You have to be a little bit more forceful with them because it's harder to get the labeled data, to get the scale of data, etc.
Although, as an interesting aside, there's some really great simulated stuff that's going on in the
definitely
self-driving
car
self-driving.
It's just like Grand Theft Auto 5, just drive around.
Yeah, why not? Get out there and simulate your data.
Does it? Every time you hit a pedestrian, does it give you points or something? And so now, got to watch out for that. That's choosing your reward function.
That is
choose the right one. You want to minimize.
For anybody that's a David Carradine fan and a Sylvester Stallone fan, check out the original Death Race.
Yeah,
there you go.
Yeah.
that's
similar.
That's where the point system comes from that everybody thinks of with cars.
Oh, okay. Okay. Well, I think that's it. We have that's it that we're gonna cover on the AI show today. Thanks for joining us. What questions do you have about AI? Comment on YouTube or Twitch, or tweet us at DeepGramAI. We are Scott and Susan from DeepGram. We come in peace.
We're certainly not robots.
Definitely not. And see you next time.
Wow. Okay.
Okay, we're back.
All right. 1, 2, 3, 4.
Unicorn. Oh, I did it.